Hello, in this lecture we'll answer two questions. The first question will find out the length of this short line segment AQ is equals to x. We have to find out the value of x. And in the second question we'll find out the area of this quarter circle A or B. So we'll start with the first question. In the drawing we have semicircle APCB. We know that this is line segment QC. This is equals to 6 units in itself. This is angle PQC. This is the right angle. This is called CB. This is equals to 5 units in itself. And we also know that arc AP equals to arc CB in its length. Those two arcs are equal to each other in their lengths. Again, our task is to find out the length of this short line segment AQ that is equals to x. We have to find out the value of x. So first of all, this is triangle ACB. Triangle ACB, subtend on this chord AB, this is the diameter of this semicircle. And according to rule 7, any triangle that subtend on the diameter of the circle or a semicircle must be equal to 90 degrees in its size. Therefore, this triangle ACB must be equal to 90 degrees in its size. So repeat quickly on rule 7. According to rule 7, if a peripheral angle subtend on the diameter of the circle or semicircle, then it is equal to 90 degrees in its size. In the drawing, we have a circle. This is peripheral ACB that subtend on this chord AB, that is the diameter of this circle, and therefore peripheral ACB equals to 90 degrees in its size. So according to this rule 7, any peripheral angle that subtend on the diameter of the circle or semicircle must be equal to 90 degrees in its size. So this is peripheral angle ACB that subtend on chord AB, that is the diameter of this semicircle, and therefore according to rule 7, it must be equal to 90 degrees in its size. AB is the diameter of this semicircle, so it is known. It is given us the question that this is arc PA and it is equals to arc CB in its length. So it is known. Arc PA equals to arc CB in its length according to what is given as the question. The rounded line above PA and CB is the sign for arc. It means that arc PA equals to arc CB in its length. And whenever you have two arcs in the circle or semicircle that are equal to each other, you can implement rule 56. So I'm clicking on rule 56. According to rule 56, if two arcs are equal in length, then their corresponding chords are also equal in their lengths. In the drawing, we have a circle. This is arc AB. Is equal to this arc CB in its length. So those two arcs are equal to each other. And therefore, their corresponding chords must be also equal to each other in their lengths. The corresponding chord of this arc is AB, and the corresponding chord of this arc is CD. And according to this rule 56, those two corresponding chords must be also equal to each other in their lengths. That is to say, chord AB equals to chord CD in its length. So we can actually implement rule 56 in our drawing. When put in our drawing, this is arc PA, this is equal to arc CB in its length, according to what is given as the question. So we join points P and A together by straight line. This is chord PA, that is the corresponding chord of this arc PA. Likewise, this is chord CB, this is equals to 5 units in itself, and chord CB is the corresponding chord of arc CB. And according to Rule 56, because of the fact that those two arcs are equal to each other in their lengths, their corresponding chords must be also equal to each other in their lengths. That is to say, chord PA equals to chord CB in its length. So according to Rule 56, chord PA is equal to chord CB in its length. But it is given us the question that this is chord CB, this equals to 5 units in its length. So we can write that CB equals to 5. And from this equation, PA equals to CB equals to 5. We will derive that chord PA must be also equal to 5 units in its length. PA also equals to 5 units in its length. According to Rule 56. So actually, this is chord PA, this is equals to 5 units in its length. So you know. In the next step, we will join points P and C together by straight line. By joining points P and C, we can get here triangle PQA. This is triangle PQA, and it's also triangle PCA. Again, this is triangle PCA. Triangle PCA is subset on this chord PA. This equals to 5 units in its length. Likewise, this is the second triangle. This is actually triangle BAC. Triangle BAC subset on chord CB that is also equals to 5 units in its length. And because of the fact that those two peripheral angles, they subset on equal chords, that must be also equal to each other in their sizes according to Rule 57. So repeat quickly on Rule 57. According to Rule 57, if two peripheral angles subset on equal chords, then they are equal to each other in their sizes. So in the drawing we have a circle. This is triangle BAC that subset on chord AB. Likewise, this is triangle EDF that subset on chord EF. And we know that chord EF equals to chord AB in its length. And therefore, those two peripheral angles that subset on equal chords must be also equal to each other in their sizes. That is to say, triangle BCA must be equal to triangle EDF in its size, or alpha equals to beta. So whenever you have two peripheral angles that subset on equal chords, they must be also equal to each other in their sizes. So we can implement Rule 57 in our drawing. Well, in our drawing, this is triangle PCA that subset on chord AP that equals to 5 units in its length, and this is triangle ACB, CAB that subset on chord CB that also equals to 5 units in its length. And because of the fact that those two peripheral angles subset on equal chords, they must be also equal to each other in their sizes. So according to Rule 57, because of the fact that those two peripheral angles subset on equal chords, they must be equal to each other in their sizes. That is to say, triangle PCA must be equal to this triangle CAB. But again, if we found out that according to Rule 57, triangle PCA must be equal to triangle CAB in its size because of the fact that they both subset on equal chords. So if we define the size of this triangle CAB as alpha, then the sides of this triangle PCA must be also equal to alpha because they are equal to each other according to rule 57. So if triangle CAB equals to alpha, then triangle PCA must be also equal to alpha. So in this right triangle PQC, so in this right ring triangle PQC, this angle equals to alpha, this angle equals to 90 degrees, and therefore this third missing angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. Likewise, in this right lower triangle ACB, this angle equals to alpha, this angle equals to 90 degrees, and therefore this third angle must be equal to 90 degrees minus alpha, according to the sum rule that states that the sum of the angles in any triangle is equal to 180 degrees. It is very easy to see that the green right triangle PQC is similar to this right lower triangle ABC according to angle similarity rule. So why those two right triangles are similar to each other? First of all, those two angles are both equal to alpha and therefore they are equal to each other. In addition, those two angles are both equal to 90 degrees minus alpha and therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees and therefore they are equal to each other. So actually found out that all the figures of this right ring triangle PQC are corresponding equal to all the figures of this right lower triangle ABC. Therefore, those two right triangles are similar to each other according to angle similarity rule. So, now we also found out that this is the green right triangle PQC, and it is similar. This is the sign of similar to this right lower triangle ABC according to angle similarity rule. Repeat again. The right ring triangle PQC is similar to the right lower triangle ABC according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we will derive that the following relationship exists between their sides. We will derive that side PQ of this green right triangle PQC over side CB of this right lower triangle ABC is equal to side QC of this green right triangle PQC over side AC of this right lower triangle ABC. And again, from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We derive that side PQ of the green triangle over side CB of the right lower triangle ABC equals to side QC of the green triangle over side AC of the right lower triangle ABC. PQ is the missing side, so if this it is, over CB is 5, and it is equals to QC equals to 6 units in itself according to what is given as the question. Over AC total equals to AQ, that is X, plus QC, that is 6. So in total AC equals to X plus 6 units in itself. So in total we found out that pq over 5 equals to 6 over x plus 6. Here we will multiply this equation by 5. And finally get that the missing side pq is equal to 6 times 5 is 30 over x plus 6 units in its length. Repeat again, if you found out that this is the missing side PQ, this equals to 30 over x plus 6 units in its length. So I write it down. The missing side PQ equals to 30 over x plus 6 units in its length. According to what is given as a question, AC is a straight line. So if you focus on the upper side of the straight line AC at point Q, here the sum of the areas must be equal to 180 degrees according to rule 3. Rule 3 says that the sum of the areas on one side of the straight line is equal to 180 degrees. So which areas we have at the upper side of the straight line AC at point Q? We have this angle that is a right angle, plus this missing angle. In total, the sum of those two angles must be equal to 180 degrees according to rule 3. Therefore, this missing angle must be equal to 90 degrees in its size. And therefore, the triangle PQA is a right angle. So the next step, we will implement the Pythagoras theorem on this right small triangle PQA. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So in this right triangle PQA, here by PT is the version for Pythagoras theorem. So in this triangle PQA, PA squared, that is the square of the hypotenuse, is equal to PQ squared plus AQ squared. And again, this right small triangle PQA, according to the Pythagoras theorem, PA squared, that is the square of the hypotenuse, equals to PQ squared plus AQ squared. PA equals to 5, and therefore PA squared is 5 squared, that is 25. And it is equals to PQ squared. PQ is 30 over x plus 6, and therefore PQ squared equals to 30 over x plus 6 squared. Plus AQ squared. AQ is the line segment that you are looking for this question. So AQ is x, therefore AQ squared is x squared. So in total, we have found out that 25 equals to 30 over x plus 6 squared plus x squared. So 25 equals to 30 over x plus 6 squared equals to 30 squared, that is 900 over x plus 6 squared. So in total, this expression equals to 900 over x plus 6 squared plus x squared. So 25 equals to 900 over x plus 6 squared. And we have here x squared. So here we will multiply x squared by x plus 6 squared, then we divide it by x plus 6 squared in order to have a common factor with this number. So we have x squared times x plus 6 squared over x plus 6 squared. We multiply it by x plus 6 squared, and then we divide it by x plus 6 squared, so we change nothing. So in total, we found out that 25 equals to 900 plus x squared times x plus 6 squared over x plus 6 squared. So if we multiply this equation by x plus 6 squared, and finally get that 25 times x plus 6 squared equals to 900 plus x squared times x plus 6 squared. So here 25 times x plus 6 squared. X plus 6 squared equals to x squared plus 6 squared, that is 36, plus 2 times x times 6, that is 12x. And it is equals to 900 plus x squared, and we have x plus 6 squared equals to x squared plus 6 squared, that is 36, plus 2 times x times 6, that is plus 12x. So here we will open the brackets on both sides of this equation, and we get that 25 times x squared is 25x squared. And remember, 25 times 36 is 900, plus 25 times 12x is 400x. On the other side of the equation, we have 900, plus, we'll open the brackets of this expression, and we get that x squared times x squared is x to the power of 4, plus x squared times 36 is 36x squared, plus x squared times 12x is 12x cubed. So here we have 900 on both sides of this equation, so 900 will get cancelled. After I cancel 900, what is left on this side of the equation? We left only with 25x squared plus 300x equals to, on the other side of the equation, we left with x to the power of 4 plus 12x cubed plus 36x squared. So here we subtract from this equation 36x squared, and we will subtract from this equation 25x squared. So in this side of the equation we left only with 300x equals to x to the power of 4 plus 12x cubed, and we have 36x squared minus 25x squared is 11x squared. So in total we found out that 300x equals to x to the power of 4 plus 12x cubed plus 11x squared. Here we will subtract 300x from this equation, and finally get that x cubed, x to the power of 4 plus 12x cubed plus 11x squared minus 300x equals to 0. Okay, so here we'll take x as a common factor from this expression. So here we have x is taken out as a common factor from this long expression. So inside the brackets, what is left from this expression is x cubed. What is left from this expression after we took from it x as a common factor? What is left is actually 12x squared. Plus, what is left from this expression after we took from it x as a common factor? What is left is actually 11x. What is left from this expression after we took from it x as a common factor? What is left is actually minus 300, and it is equals to 0. So in total, this expression equals to x times x cubed plus 12x squared plus 11x minus 300 equals to 0. So we have two solutions to this equation. The first solution for x is that x equals to 0. If x equals to 0, then 0 times anything is 0. We get that 0 equals to 0. So x equals to 0 is true for this equation, because we get that 0 equals to 0. The second solution from this equation is that the expression inside the brackets equals to 0, and then 0 times anything is 0, and we get that 0 equals to 0. So the second solution for this equation is x cubed plus 12x squared plus 11x minus 300 equals to 0. Again, 0 times anything is 0, and we get that 0 equals to 0. So you have those two solutions to this equation. What about the first solution for x? X equals to 0. Actually, x can never be equal to 0 because of the fact that x is the length from right side AQ. So x as a length, it must be a positive number. So x is a length, so x as a length, it must be a positive number. Therefore, x can never be equal to 0, that is not a positive number. X must be a positive number. The second solution for x is this expression equals to 0. So, first of all, we check if x equals to 3 is solve this equation. So if x equals to 3, then the value of this equation in total will be equal to, so we just substitute x by 3, and we get that if x equals to 3, then x squared equals to 3 squared. 3 squared is 3 times 3 times 3, that is 27, plus 12x squared. X is 3, therefore x squared is 3 squared, that is 9. 9 times 12 is 108. Plus 11x. X is 3, so 11x is x times 3, that is 33, minus 300. It must be equal to 0. 27 plus 108 plus 36, in total it is equal to 186. Again, this the sum of those three numbers, in total it is 168. So it is 168 minus 300 is definitely not equal to 0. So if x equals to 3 is not the solution for this equation. In the next step, we'll check that if x equals to 4 is the solution of this equation. So if x equals to 4, you just have to substitute x by 4 in this equation. If x equals to 4, then this equation, we have x cubed is 4 cubed. 4 cubed is 4 times 4 times 4, that is 64. Plus 12x squared. X is 4, so x squared is 4 squared, that is 16. 16 times 12 is 192. Plus 11x. X is 4, so 11x is 11 times 4, that is 44, minus 300, equals to 0. 64 plus 44 is 108, and 108 plus 192 is 300, and 300 minus 300 is indeed equals to 0. So if x equals to 4, then x equals to 4 is the solution for this equation. So we have the equation that says that x cubed plus 12x squared plus 11x minus 300 equals to 0. Now we know that x equals to 4 is the solution for this equation. Therefore, this expression in total is equal to this expression in total equals to x minus 4 times x squared plus 16x plus 75. Repeat again. Those two expressions are identical. That is to say, if you open the brackets of this equation, we get that this expression in total equals to x cubed plus 12x squared plus 11x minus 300. So we can substitute this expression by this expression because those two expressions are identical. So this expression equals to 0, so this expression must be also equal to 0 because they are identical to each other. Now it is very easy to solve this equation. It is very easy to see that this equation has two solutions that are possible. The first solution to this equation is that x minus 4 equals to 0. If x minus 4 equals to 0, then 0 times anything is 0. You get that 0 equals to 0. So the first solution for this equation is x minus 4 equals to 0. And the second solution for this equation is this expression equals to 0. And 0 times x minus 4 is 0. You get that 0 equals to 0. So the second solution for this equation is that x squared plus 16x plus 75 equals to 0. Those are the two solutions that are possible for this equation. X minus 4 equals to 0, so we add 4 to this equation, and we get that x equals to 4. So the first solution to this question is that x let's write AQ is equals to x is equals to 4 units in itself. But maybe this equation has another solution. Maybe x can be equal to another value. So we have to check that if x squared plus 16x plus 75 indeed could be equal to 0. X squared plus 16x plus 75 is a quadratic equation. And the general formula for a quadratic equation is as follows: ax squared plus bx plus c equals to 0. This is the general formula for a quadratic equation. In this general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And when we find out the value of x according to the following formula, x equals to minus b plus minus square root of b squared plus 4 times a times c over 2a. Okay, this is the general formula for x. This b squared plus 4 times ac is the determinant of this quadratic equation. But again, this expression inside the root is actually b squared minus 4 times a times c is the determinant of this quadratic equation in this general formula. I repeat again, a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. In our specific quadratic equation, the coefficient b equals to 16, the coefficient a equals to 1, and the coefficient c equals to 75. B squared minus 4 times a times c is the determinant of this quadratic equation, and we know that any number, only a positive number has a root. That is to say, the determinant of b squared minus 4 times ac must be a positive number. That is to say, if the determinant b squared minus 4 times ac is a negative number, then there is no solution to this quadratic equation. Why? Because of the fact that when the determinant is negative, then the quadratic equation has no real solution. Okay, again, if the determinant b squared minus 4 times a times c of this quadratic equation is negative, then this quadratic equation has no solution, because you don't have root to a negative number. Okay? There is no real solution to a negative number. Therefore, the determinant b squared minus 4 times a times c must be greater than 0 in order that this quadratic equation has any solutions at all. So we check what is the determinant of this quadratic equation: x squared plus 16x plus 75. So the determinant of this quadratic equation equals to b squared. B is 16, therefore b squared is 16 squared. This is 256 minus 4 times a times c. A is also minus 4 times a is minus 4 times 1 is minus 4 times c. Minus 4 times c is minus 4 times 75. This is minus 300. So the determinant of this quadratic equation equals to 256 minus 300. That is definitely a negative number. And because of the fact that the determinant of this quadratic equation is a negative, it means that this quadratic equation has no solutions at all. And because of the fact that this quadratic equation has no solutions at all, we cancel this option. This is not the solution for this equation. We have another reason that this is not the solution of this equation. Why? Because we can substitute 75 by 64 plus 11. So this expression in total equals to x squared plus 16x, and 75 is 64 plus 11 equals to 0. X squared plus 16x plus 64 is equals to x minus 8 squared. If you just open the brackets here, we get that x minus 8 squared equals to x squared plus 16x plus 64 plus 11 equals to 0. Here we subtract 11 from this equation, and we get that x minus 8 squared equals to minus 11. X minus 8 squared is a positive number, and a positive number can never be equal to a negative number, because minus 11 is a negative number. So, therefore, that is the second reason that is not the correct solution for this equation. So, two reasons why this is not the solution to this equation. And therefore, we have only one solution for x, that is to say, x equals to 4. So if we found out that the length of this line segment a cubed equals to x is equal to 4 units in itself. That is the answer to the first question. So we finish with the first question. In the next step, I will present you the second question, and we will solve the second question of this lecture. In this second question, our task is to find out the area of this quarter circle A or B. So, in the drawing, we have quarter circle A or B. This is line segment P cubed, is equals to 4 units in itself. This is line segment A cubed, is equals to 4 units in itself. This is the angle PQ8, that is the right angle. Again, our task is to find out the area of this quarter circle A or B. OB equals to OA, the above the radii of this quarter circle, therefore they are equal to each other. So if we define the radius of this quarter circle is R, then OA equals to R. And OB is also the radius of this quarter circle, therefore it is equal to R according to our definition. We have the rule that says that in front of equal sides in the triangle there are equal angles. So in front of those two equal sides, we have those two angles that must be equal to each other in their sizes, according to the rule that I mentioned. So if we define the size of this angle as x, then the size of this angle must be also equal to x according to the rule that I mentioned. In front of equal sides in the triangle there are equal angles. We also know that the sum of the angles in a triangle is equal to 180 degrees. So which angles we have in this right triangle A or B? X plus x is 2x plus 90 degrees, in total must be equal to 180 degrees. So in the right triangle A or B, the sum of the angles must be equal to 180 degrees. That is to say, 2x plus 90 degrees must be equal to 180 degrees. Here we subtract 90 degrees from this equation, and we get that 2x equals to 180 degrees minus 90 degrees is 90 degrees. So 2x equals to 90 degrees. Here we divide this equation by 2, and finally we get that the missing angle x equals to 90 degrees over 2, that is 45 degrees. So actually, this is the missing angle x, is equals to 45 degrees inside. Likewise, this is also the missing angle x, is equals to 45 degrees inside. In the next step, we will do a construction, that is to say from point O, that is the center of this quarter circle, we will do perpendicular on AB. Again, from point O, we will do perpendicular on AB. So actually, this angle equals to 90 degrees in size, and this angle also equals to 90 degrees in size according to our construction. We will define the touching point of the perpendicular from point O and AB. This point is point M. By doing this construction, we get the right triangle, triangle AMO. This is the right triangle AMO. The sum of the angles in the right triangle AMO must be equal to 180 degrees. That is to say, 45 degrees plus 90 degrees is 135 degrees, so 135 degrees plus the size of this third missing angle in total must be equal to 180 degrees. And therefore this third missing angle must be equal to 45 degrees in size. We also have the rule that states that in front of equal angles in the triangle there are equal size. So in front of, in the right triangle AMO, in front of those two equal angles, we have those two sides that must be also equal to each other and their lengths. That is to say, side AM equals to side MO in this right triangle, triangle AMO. AM equals to MO. In the right triangle AMO, according to the rule that I mentioned, side AM must be equal to side MO. Side AM equals to side MO. We define the length of this line segment AMQ as x. So in total, AM equals to 4 plus x. So you can write that AM equals to 4 plus x. And from this equation 4 plus x equals to am equals to mo, we will derive that the missing side mo must be also equal to 4 plus x units in its length. Mo equals to 4 plus x. In the next step, we will implement the Pythagoras theorem on this right triangle, triangle mo. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the surface of the perpendiculars. Here by PT is the proportion for Pythagoras theorem. So in this right triangle mo, according to the Pythagoras theorem, AO squared, this is the square of the hypotenuse, must be equal to AM squared plus MO squared. We already found out that MO equals to 4 plus x units in itself. Actually, the right triangle AMO is also an associated triangle because of the fact that those two sides are equal to each other, each side equals to x plus 4 units in itself. Or 4 plus x. So AO is the missing side, so we leave it as it is, so it is AO squared. And again, in the right triangle AOM according to the Pythagoras theorem, AO squared equals to AM squared plus MO squared. AO is the missing side, so we leave it as it is, and it is equal to AM. AM is x plus 4, and therefore AM squared is x plus 4 squared plus MO squared. MO is also x plus 4, and therefore MO squared equals to x plus 4 squared. So in total, we actually know that AO squared equals to x plus 4 squared plus x plus 4 squared. So AO squared equals to 2 times x plus 4 squared. So here we'll take a root out of this equation and finally get that the missing hypotenuse AO is also the radius of this quarter circle R. So AO, this is also the radius of the quarter circle. In total, this equals to the square root of 2, and the square root of x plus 4 squared equals to x plus 4. So in total, we found out that the radius AO of the quarter circle equals to the square root of 2 times x plus 4 units in its length. This is the radius AO of the quarter circle. This equals to the square root of 2 times x plus 4 units in its length. So it is known. The radius of the quarter circle equals to the square root of 2 times x plus 4 units in its length. In the next step, we will do another construction. That is to say, we will draw perpendicular on this short line segment PQ at point P. Again, we will draw perpendicular on this short line segment PQ at point Q. So here, this angle equals to 90 degrees according to our construction. And we will extend the perpendicular OM by side line until it touches the extended perpendicular from point P. And we will define the touching point of the extended perpendicular OM with the perpendicular from point P. This point is point N. According to what actually OM is a perpendicular, so OM is a perpendicular, it is absolutely a straight line. When you extend the straight line by straight line, the result ON must be also a straight line. So ON is a straight line, So if you focus on the upper side of the straight line ON at point M, here the sum of the, if you focus on the lower side of the straight line ON at point M, here the sum of the areas must be equal to 180 degrees according to rule 3. Rule 3 states that the sum of the areas on one side of a straight line is equal to 180 degrees. So which angles we have at the lower side of the straight line ON at point M, we have this angle that is the right angle, plus this missing angle. In total, the sum of those two angles must be equal to 180 degrees according to rule 3. Therefore, this missing angle must be equal to 90 degrees in its size. Likewise, it is given us the question that AB is a straight line. So if you focus on the upper side of the straight line AB at point Q, here the sum of the angles must be equal to 180 degrees according to the sum rule 3. So which angles we have at the upper side of the straight line AB at point Q? We have this angle that is the right angle, plus this missing angle. In total, the sum of those two angles must be equal to 180 degrees according to rule 3. Therefore, this missing angle must be equal to 90 degrees in its size. So in quadrilateral NMQP, we have 1, 2, 3 right angles. The sum of 3 right angles is of course 270 degrees. So 270 degrees plus the size of these 4 missing angles is a triangle PNM. In total, it must be equal to 360 degrees. According to the rule that states that the sum of the angles in any quadrilateral is equal to 360 degrees. So write it down. In quadrilateral NMQP, the sum of the angles must be equal to 360 degrees. That is to say, 270 degrees plus the size of this fourth missing angle, this angle P and M. In total, it must be equal to 360 degrees. And again, in quadrilateral NMQP, the sum of the angles must be equal to 360 degrees. That is to say 270 degrees plus the size of the fourth missing angle is actually angle P and M. In total, it must be equal to 360 degrees. Here we subtract 270 degrees from this equation. And we get that the missing angle P and M, the size of the missing angle P and M is equal to 360 degrees minus 270 degrees is 90 degrees. So it is a right angle. This is the missing angle P and M, that is a right angle. So in quadrilateral P and MQ we have 4 right angles, and therefore we can relate to quadrilateral P and MQ as a rectangle. So it has 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle P and MQ, side PQ must be equal to the opposite side NM. But PQ is 3, therefore the opposite side NM must be also equal to 3 units in its length. Likewise, according to the sum rule, in the same rectangle NMQP, side QM must be equal to the opposite side PN. But QM, again, side QM must be equal to the opposite side PN. But QM is X, therefore the opposite side PN must be also equal to X units in its length. In the next step, we will join points O and P together by a straight line. Point O is the center of this quarter circle. Point P is the point of the quarter circle itself. Therefore, OP is the radius of this quarter circle. We already found out that the radius of this quarter circle AOB equals to the square root of 2 times x plus 4. Therefore, the radius of OP equals to the square root of 2 times x plus 4 units in its length. In the next step, we will implement the quadratic theorem on this triangle P and O. Repeat again. We will implement the quadratic theorem on this right triangle P and O. Here by PT is the evaluation from Pythagoras theorem. In this general P and O, according to the Pythagoras theorem, P all squared, that is the square of the hypotenuse, equals to Pn squared plus NO squared. Because again, in this right P and O, according to the Pythagoras theorem, P all squared, that is the square of the hypotenuse, equals to Pn squared plus NO squared. We already found out that the radius PO equals to the square root of 2 times x plus 4. And therefore, P all squared must be equal to square root of 2 times x plus 4 squared. Then again, P all squared in total must be equal to the square root of 2 times x plus 4 squared. And it is equal to Pn squared. Pn is x, therefore Pn squared is x squared plus NO squared. NO in total equals to Cm, that is x plus 4, plus Mn, that is 3. So in total, or n equals to x plus 7. So NO equals to x plus 7, and therefore NO squared equals to x plus 7 squared. So in total, we found out that square root of 2 times x plus 4 squared equals to x squared plus x plus 7 squared. We'll open the brackets on this, both sides of this equation, and finally get that square root of 2 square is 2, and we have also times x plus 4 squared. And it is equals to x squared plus x plus 7 squared. X plus 7 squared equals to x squared plus 7 squared, that is 49, plus 2 times x times 7, that is 14x. So in this side of the equation we have 2 times x plus 4 squared. X plus 4 squared equals to x squared plus 4 squared, that is 16, plus 2 times x times 4, that is 8x. Here we have, on the other side of the equation, we have x squared plus x squared, it is 2x squared, plus 49, plus 14x. We'll open the brackets on this side of this equation. We have 2 times x squared is 2x squared, plus 2 times 16 is 32, plus 2 times 8x is 16x, and it equals to 2x squared plus 49 plus 14x. Here we have 2x squared on both sides of this equation, so 2x squared will get cancelled. Or they will cancel 2x squared. In this side of the equation, we left only with 32 plus 16x, while on the other side of this equation, we left only with 49 plus 14x. So here we subtract 14x from this equation, and finally get that 32 and 16x plus 14x is 2x, and is equals to 49, because 14x plus 14x is 0. Here we subtract 32 from this equation, and finally get that 2x equals to 49 minus 42 is 17, so 2x equals to 17. Here we will divide this equation by 2 and finally get that the missing answer x is equal to 17 halves. X equals to 17 halves. Actually, what is x? X is the length of this line segment PN is equal to 17 ops, and this is line segment QM is equal to X is also equal to 17 ops units in its length. So X equals to 17 ops units in its length. Our task is to find out the area of this quarter circle A or B. So what is the area of this quarter circle? A or B. Okay, again, our test is to find out the area of this quarter circle A or B. What is the area of this quarter circle A or B? Any quarter circle is 1/4 of a circle. The area of a circle is pi times the radius of the circle squared, and therefore the area of the quarter circle A or B must be equal to pi times the radius of the circle squared over 4. So the area of this quarter circle A or B must be equal to pi times the radius of the circle squared over 4. And again, the area of the quarter circle A or B must be equal to pi times the radius of the quarter circle squared over 4, because it is 1/4 of a circle. We already found out that, so it is pi over 4 times the radius of the circle squared. We already found out that the radius of this quarter circle equals to the square root of 2 times x plus 4. And again, the radius of this quarter circle equals to the square root of 2 times x plus 4. And therefore the radius square must be equal to the square root of 2 times x plus 4 squared. We'll open the brackets of this expression, and again that this expression in total equals to pi over 4. So inside the brackets we have square root of 2 squared is 2 times x plus 4 squared. 2 over 4 is 1/2, so this expression in total equals to pi over 2 times x plus 4 squared. We already found out that x equals to 17 halves, so we can substitute x by 17 halves. So it is 17 halves plus 4 squared. So in total we found out that the area of this quarter circle A or B is equal to pi over 2 times 17 halves plus 4 squared. So it is pi over 2 times 17 halves plus 4 squared. So here we multiply 4 by 2 and then we divide it by 2 in order to come part of this number. 4 times 2 is 8. And then we divide by it, so we change nothing. So this operation is allowable. So in total we found out that the area it is squared, of course. The area of the quarter circle equals to pi over 2 times 17 plus 8 over 2 squared. So it is pi over 2. 17 plus 8 is 25 over 2 squared. So the area of this quarter circle A or B in total equals to pi over 2, and we have 25 over 2 squared equals to 25 squared, that is 625, over 2 squared, that is 4. So in total, if you found out that the area that we are looking for this equation, that is the area of this quarter circle, is equal to the numerator of this expression, we have 625 pi over 4 times 2, that is 8. So the area of this quarter circle in total equals to either 625 pi over 8 squared inside, or in terms of numbers, the area of this quarter circle is equal to 245.437 square meters inside. But again, we should find out that the area that we are looking for in this question, that is the area of this quarter circle. In total, it is equal to either 625 pi over 8 square units in size. So in terms of numbers, the area of this quarter circle will be equals to 245.437 square units in size. So we finished to answer on the second question. In the next step, I'll summarize the lecture. That is to say, I'll repeat on the solution of the first question and then repeat on the solution of the second question. In the first question, our task was to find out the length of this short line segment AQ is equals to x. We have to find out the value of x. So in the domain, we have semicircle APCB. This is line segment QC, this is equals to 6 units in its length. This is called CB, this is equals to 5 units in its length. This is angle PQC, this is a right angle. And we also know that arc AP equals to arc CB in its length. Again, those two arcs are equal to each other in their lengths. Again, our task is to find out the length of this short line segment AQ is equals to x. We have to find out the value of x. This is peripheral ACB. Peripheral ACB. This is peripheral angle ACB. The subtend on chord AB. This is the diameter of this semicircle, and we know that any peripheral angle that subtend on the diameter of the circle or semicircle must be equal to 90 degrees in its size. Therefore, peripheral ACB must be equal to 90 degrees in its size according to rule 7. In addition, it is given us the question that it is given us in the question that arc PA equals to arc CB in its length. Whenever we have two arcs that are equal to each other in the circle or semicircle, we can implement rule 56. According to rule 56, the corresponding chords of two arcs that are equal to each other in their lengths must be also equal to each other. The corresponding chord of this arc PA is chord PA, and the corresponding chord of this arc CB is chord CB. So, if the two arcs are equal to each other in their lengths, then their corresponding chords must be also equal to each other in their lengths. That is to say, chord PA equals to chord CB in its length according to rule 56. Okay, again, because of the fact that it is given us a question that arc PA equals to arc CB in its length, therefore their corresponding chords must be also equal to each other in their lengths. That is to say, chord PA must be equal to chord CB in its length according to rule 56. But it is given us a question that chord CB equals to 5. So we can write it that CB equals to 5, and for this equation PA equals to CB equals to 5, we will write that chord PA must be also equal to 5 units in its length. This is chord PA, is equal to 5 units in its length according to rule 56. In the next step, we join points P and C together by straight line. By joining points P and C, we get here peripheral PCA. Peripheral PCA, this is peripheral PCA that subtend on chord P8 is equal to 5 units in its length. Likewise, this is peripheral CAB. Peripheral CAB subtend on chord CB is also equals to 5 minutes in itself. And because of the fact that those two peripherals subtend on equal chords, that equals to 5 minutes, they must be equal to each other and their sizes, according to Rule 57. So if you define the size of this peripheral alpha, then the size of this peripheral must be also equal to each other, to alpha, because they are equal to each other according to Rule 57. So in this entire PQC, this entire PQC, this angle equals to alpha, this angle equals to 90 degrees, and therefore this first angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. Likewise, this right lower triangle ABC, this angle equals to alpha, this angle equals to 90 degrees, and therefore this first angle must be equal to 90 degrees minus alpha, according to the rule that says that the sum of the angles in any triangle is equal to 180 degrees. In the next step, we prove that the green right triangle PQC is similar to this right lower triangle, triangle ABC. So why those two right triangles are similar to each other? First of all, those two angles are both equal to alpha, and therefore they are equal to each other. In addition, those two angles are both equal to 90 degrees, and therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees minus alpha, and therefore they are equal to each other. So we found out that all the fingers of this green right triangle PQC are corresponding equal to all the fingers of this right lower triangle ABC, and therefore those two right triangles are similar to each other according to an angle similarity rule. So repeat again, we found out that the right triangle PQC is similar, this is the sign of similar, to the right lower triangle ABC according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We will derive that side PQ of this right triangle PQC over side CB of this right lower triangle ABC is equal to side QC of this right triangle PQC or side AC of this right lower triangle ABC. But again, from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We will derive that side PQ of the green triangle or side CB of the right lower triangle ABC equals to side QC of the green triangle or side AC of the right lower triangle ABC. PQ is the missing side, so we leave this it is, over CB. CB is 5, QC is 6, and AC in total equals to x plus 6. So AC equals to x plus 6, so in total we found out that PQ over 5 equals to 6 over x plus 6. Here we multiply this equation by 5 and found out that the missing side PQ equals to 5 times 6 is 30 over x plus 6. Again, this is the missing side PQ, this is equals to 30 over x plus 6 units in itself. AC is a straight line, according to what is given as the question. And if you focus on the upper side of the straight line AC is point Q, here the sum of the angles must be equal to 180 degrees according to Rule 3. So which angles we have at the upper side of the straight line AC at point Q? We have this angle, that is the right angle, plus this missing angle. In total, the sum of those angles must be equal to 180 degrees according to Rule 3. Therefore, this missing angle must be equal to 90 degrees in size. And therefore, triangle PQA is the right angle. So in the next step, we implement the Pythagoras theorem on this right triangle PQA. According to the Pythagoras theorem on this right triangle PQA, PA squared, that is the square of the hypotenuse, equals to PQ squared plus QA squared. But again, in this right triangle PQA, according to the Pythagoras theorem, PA squared, that is the square of the hypotenuse, equals to PQ squared plus AQ squared. PA is 5, therefore PA squared is 5 squared, that is 25, and it equals to PQ squared. PQ is 30 over x plus 6, and therefore PQ squared equals to 30 over x plus 6 squared, plus QA squared. QA is x, therefore QA squared is x squared. So in total, we found out that 25 equals to 30 over x plus 6 squared plus x squared. So 25 equals to 30 over x plus 6 squared. We open the brackets of this expression. This expression in total equals to 30 squared, that is 900 over x plus 6 squared plus x squared. So here we have 25 equals to 900 over x plus 6 squared plus x squared. So here we multiplied x squared by x plus 6 squared, and then we divided by x plus 6 squared in order to overcome factor with this number. So in total we found out that 25 equals to 900 over x plus 6 squared, and we multiply x squared by x plus 6 squared, and then we divided by x plus 6 squared, therefore we change nothing. This operation is lovable. So in total, we found out that 25 equals to 900 plus x squared times x plus 6 squared over x plus 6 squared. Here we multiply this equation by x plus 6 squared, and finally found out that 25 times x plus 6 squared equals to 900 times x squared plus x plus 6 squared. So we have 25 times x plus 6 squared. X plus 6 squared equals to x squared plus 6 squared, that is 36, plus 2 times x times 6, that is 12x. And is equals to 900 times x squared plus x plus 6 squared. So it is x squared times x plus 6 squared. X plus 6 squared equals to x squared plus 6 squared, that is 36, plus 2 times x times 6, that is 12x. Open the brackets of this expression. This 25x times x squared is 25x squared, plus 25 times 36 is 900, and we have 25 times 12x is 300x. In the other side of the equation we have 900, and we have here x squared times x squared plus 36 times 12x. So we open the brackets of this expression. X squared times x squared is x to the power of 4. X squared times 36 is 36x squared, and we have x squared times 12x is equal to 12x cubed. So here we have 900 on both sides of this equation, so 900 we get cancelled, so we cancel 900. In this side of the equation we left only with 25x squared plus 300x, while on the other side of this equation we left with x cubed plus 12x to the power of 4 plus 12x cubed plus 36x squared. So here we subtract 25x squared from this equation. So on this side of the equation we left only with 300x, while on the other side of the equation we have x cubed plus 12x to the power of 4 plus 12x cubed, and we have 36x squared minus 25x squared is 11x squared. So in total we found out the 300x equals to x to the power of 4 plus 12x cubed plus 11x squared. Here we subtract the 300x from this equation, and finally found out that x cubed plus 12x x to the power of 4 plus 12x cubed plus 11x squared minus 300x equals to 0. Here we took out x as a common factor from this expression, so inside the brackets we left with x cubed plus 12x squared plus 11x minus 300 equals to 0. So this equation has two solutions. The first solution is that x equals to 0. If x equals to 0, then 0 times anything is 0. We get that 0 equals to 0. That is the first solution for x. And the second solution for x is that this expression inside the brackets equals to 0. And then we have 0 times x equals to 0, so 0 equals to 0. So those are the two solutions for x, for this equation. But the problem is that x can never be equal to 0. Because x is the length of line segment AQ, it must be a positive number. Repeat again. X is a length, and x is a length, it must be a positive number. It can never be equal to 0, that is definitely not a positive number. So we'll take into account only the second solution for x. The second solution for x, that this expression equals to 0. That is to say x cubed plus 12x squared plus 11x minus 300 equals to 0. First of all, we checked if this expression, if this equation is true, if x equals to 3. So we just have to substitute x by 3 in this equation. So x3 is 3, x to the x cubed is 3 cubed. 3 cubed is 3 times 3 times 3, that is 27, plus 12x squared. X is 3, so x squared is 3 squared, that is 9, so it is 9 times 12, that is 108, plus 11x. X is 3, so 11x is 11 times 3, that is 33, plus 300. 27 plus 108 plus 33 is 168, minus 300 must be equal to 0, but 168 minus 300 is definitely not equal to 0. And therefore, if x equals to 3, doesn't solve this equation, so x cannot be equal to 3. In the next step, we checked if x equals to 4, solve this equation. So we just have to solve x by 4 in order to check if x equals to 4. If x equals to 4, then x cubed is 4 times 4 times 4, that is 64, plus 12x squared. X is 4, so x squared is 4 squared, that is 16, and 16 times 12 is 192, plus 11x. X is 4, so 11x is 4 times 11, that is 44, minus 300. 64 plus 44 is 100, plus 192. 108 plus 192 is 300, and 300 minus 300 is 0. So x equals to 4 is solve this equation, and therefore we can present this equation in a different way, or we can express this equation in a different way. This expression equals to x minus 4 times x squared plus 16x plus 75. So we substitute this expression by x minus 4 times x squared plus 16x plus 75. And again, substitute this expression by x minus 4 times x squared plus 16x plus 75. So this expression equals to 0, and therefore this identical expression must be also equal to 0. If you open the brackets of this expression, we get that this expression in total equals to x cubed plus 12x squared plus 11x minus 300. So we substitute this expression by this expression. So this expression equals to 0, and therefore this identical expression must be also equal to 0. So now it is very easy to solve this equation, because we have two solutions for this equation. The first solution for this equation is that x minus 4 equals to 0. If x minus 4 equals to 0, then 0 times anything equals to 0. So we get that 0 equals to 0. So if x minus 4 equals to 0, then we just added 4 to this equation and found out that x equals to 4. So the first solution to this equation is that line side a cubed equals to x is equal to 4 in its instant. But we have another solution to this equation. If this expression equals to 0, then 0 times x plus 4, 0 times x minus 4 is 0. So we get the 0 equals to 0. But the problem is that if this expression is true, we check that if this quadratic equation is true, if x squared plus 16x plus 75 could be equal to 0. This is a quadratic equation. The general formula for a quadratic equation is as follows: ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula: x equals to minus b plus minus 4 to p squared minus 4 times a times c over 2a. In order that this quadratic equation will have any solution at all, the determinant, that is to say b squared minus 4 times a times c, must be greater than 0. So if this determinant is a negative number, it means that this quadratic equation has no solution at all. So we must check, we must verify that the determinant of this quadratic equation, that is p squared minus 4 times a times c, is not a negative number. So we have to check that the determinant b squared minus 4 times a times c is not a negative number. In this our specific quadratic equation, that is say x squared plus 16x plus 75 equals to 0, the coefficient a equals to 1, the coefficient b equals to 16, and the coefficient c equals to 75. So, and therefore the determinant of this specific quadratic equation equals to b squared minus 4 times a times c. b is 16, therefore b squared is 16 squared, that is 256, minus 4 times a times c. A is 1, so minus 4 times 1 is minus 4 times c. C is 75, so minus 4 times 75 is minus 300. So the determinant of this quadratic equation in total is equals to 256 minus 300. That is definitely a negative number. And because of the fact that the determinant of this quadratic equation is a negative number, it means that this quadratic equation has no solution at all. Therefore, we must cancel this option. That is to say, this expression can never be equal to 0. Therefore, we left only with the only solution that is left. The length of this line segment acute is equal to 4 units in its length. I presented to you another way to prove that this is not a correct solution for this quadratic equation, from this equation. Why? Because we have here x squared plus 16, x plus 75. We just substitute 75 plus 64 plus 11. So this expression in total equals to x squared plus 16x plus 64 plus 11 equals to 0. This expression x squared plus 16x plus 64 equals to x minus 8 squared. If we open the brackets of this expression, we get that this expression in total equals to x squared plus 16x plus 64, and we have plus 11 equals to 0. Here we subtract the 11 from this equation, and we find out that x minus 8 squared equals to minus 11. X minus 8 squared is a positive number, and positive number can never be equal to minus 11, that is a negative number. So I presented two explanations why x squared plus 16x plus 75 can never be equal to 0. In the first explanation, I proved that the determinant of this quadratic equation is a negative number, and therefore it is no solution at all. In the second explanation, we arrived that this quadratic equation is no solution at all, because we actually found out that according to this quadratic equation, a positive number equals to a negative number. That is impossible. So therefore, in total, the answer to this question is that the length of this line equals to x is equal to 4 units in its length. So finish to repeat on the first question. In the next step, I repeat on the solution of the second question. In the second question, our test was to find out they have this quarter circle A or B. So in the drawing we have quarter circle A or B. This is the short line segment PQ is equals to 4 units in itself. This is the short line segment QA is equals to 4 units in itself. This is the angle PQA, this is the right angle. Again, our test is to find out they have this quarter circle A or B. So first of all, point O is the center of the quarter circle, and this is the right angle. It is true for any quarter circle. In addition, we know that OB equals to OA, the above there of the quarter circle, and therefore they are equal to each other. So if we define the radius of this quarter circle OA as R, then the radius OB must be also equal to R. So in this right triangle AOB, we have the rule that states that in front of equal sides in the triangle there are equal angles. So in front of those two equal sides, there are those two angles that must be also equal to each other in their sizes. So if you define the size of this angle as x, then the size of this angle must be also equal to x, because they are equal to each other according to the rule that I mentioned. And we know that the sum of the angles in the triangle is equal to 180 degrees. So in the triangle AOB, the sum of the angles must be equal to 180 degrees. So x plus x is 2x plus 90 degrees. In total must be equal to 180 degrees. So in the right triangle AOB, the sum of the angles must be equal to 180 degrees. So that is to say 2x plus 90 degrees equals to 180 degrees. Here we subtract the 90 degrees from the equation and found out that 2x equals to 180 degrees minus 90 degrees is 90 degrees. Here we divide this equation by 2 and found out that the missing angle x equals to 90 degrees over 2, that is 45 degrees. So this is the missing angle x is equals to 45 degrees inside, and this is also the missing angle x is equals to 45 degrees inside. In the next step, we did a construction, that is to say from point O, that is the center of this quarter circle, we do perpendicular on AB. Again, from point O, we do perpendicular on AB. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and AB. This point is point M. By doing this construction, we can do the right triangle AMO. We have the rule that in a triangle in front of equal angles we have equal sides. So in the right triangle AMO, in front of those two equal angles we have those two sides that must be also equal to each other in their lengths. That is to say AM equals to MO. And again in the right triangle AMO, according to the rule that in front of equal angles in the triangle there are equal sides, side M must be equal to side MO. We define the length of side line 7 QM is x. So in total, AM equals to 4 plus x. So you can write here that AM equals to 4 plus x. And from this equation, 4 plus x equals to AM equals to OM. We write that OM must be also equal to x plus 4 in its M. This is the missing side. We write that OM must be also equal to x plus 4 units in its length. This is the missing side OM. This is equal to x plus 4 units in its length. The next step, implementing the Pythagoras theorem on this right triangle AMO. According to the Pythagoras theorem, in a right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendicular. So in this right triangle AMO, AO squared, that is the square of the hypotenuse, equals to AM squared plus MO squared. Again, in the right triangle AMO, the right and the isosceles triangle AMO, AO squared, that is the square of the hypotenuse, equals to AM squared plus OM squared. AO is the missing side, so we leave it as it is. And it's equals to AM squared. AM is x plus 4, therefore AM squared is x plus 4 squared. OM is also x plus 4, and therefore OM squared is x plus 4 squared. So in total, AO squared equals to x plus 4 squared. This is x plus 4 squared plus x plus 4 squared. X plus 4 squared plus x plus 4 squared equals to 2 times x plus 4 squared. So in total, we shall know that AO squared equals to 2 times x plus 4 squared. Here we took out the equation and we found out that the missing hypotenuse AO, that is also the radius of this angle, is equals to the square root of 2 times the square root of x plus 4 squared. The square root of x plus 4 squared equals to x plus 4. So in total, if you found out that the radius AO of this quarter circle is equals to R, in total it is equals to the square root of 2 times x plus 4 units in its length. In the next step, we did another construction, that is to say, on this line segment PQ, we do perpendicular on point P. Again, on this short line segment PQ, we do perpendicular on point P, with point P. So this angle equals to 90 degrees according to our construction. The next step, we extended the perpendicular OM by straight line until it touches the extended perpendicular P. And we find the touching point of the extended line segment OM with the extended perpendicular from point B. This point is point M. We know that AB is a straight line. It is one side of the right triangle, therefore it is a straight line. We focus on this OM is a perpendicular, it is absolutely a straight line. When you extend a straight line by straight line, the result ON must be also a straight line. So ON is a straight line. So if you focus on the lower side of the straight line ON at point M, here the sum of the angles must be equal to 180 degrees according to rule 3. Rule 3 says that the sum of the angles on one side of the straight line is equal to 180 degrees. So which angles we have at the lower side of the straight line OM at point M, you have this angle, the right angle, plus this missing angle, in total the sum of those angles must be equal to 180 degrees according to rule 3. Therefore this missing angle must be equal to 90 degrees in its size according to rule 3. Likewise, it is given us the equation that AB is a straight line. So if we focus on the upper side of the straight line AB at point Q, here the sum of the angles must be equal to 180 degrees according to rule 3. So which angles we have at the upper side of the straight line AB at point Q, we have this angle, the right angle, plus this missing angle, in total the sum of those angles must be equal to 180 degrees according to rule 3. Therefore this missing angle must be equal to 90 degrees in its size according to the same rule 3. So in total, in quadrangle NMQP, we have 1, 2, 3 angles. This angle equals to 90 degrees according to our construction, and those two angles are both equal to 90 degrees according to rule 3. The sum of 3 degrees is 270 degrees, so 270 degrees plus the size of this fourth piece angle, this is a triangle PNM, in total must be equal to 360 degrees, according to the rule that says that the sum of degrees in any quadrilateral is equal to 360 degrees. Repeat again, in quadrilateral NMQP, the sum of degrees must be equal to 360 degrees. That is to say 270 degrees plus the size of the fourth piece angle, this is angle PNM, in total must be equal to 360 degrees. So here we subtract 270 degrees from this equation, and find out that the missing angle P and M equals to 360 degrees plus 270 degrees is 90 degrees. So this is the missing angle P and M, that is right angle. So in total, in quadrilateral P and MQ we have 4 right angles, and therefore we can relate to this quadrilateral P and MQ as a rectangle. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle P and MQ, the side MQ must be equal to the opposite side NP, but MQ is x, therefore the opposite side NP must be also equal to x units in its length. Likewise, according to the sum rule, in the sum rectangle NMQP, side PQ must be equal to the opposite side NM, but PQ is 3, therefore the opposite side NM must be also equal to 3 units in its length. The next step, we join points O and P together by straight line. What is the definition of line segment OP? Line segment OP starts from point O, that is the center of this quarter circle, and that's at point P, that is the point of the quarter circle itself. So this is exactly the definition of a radius. Therefore, OP is the radius of this quarter circle. We already found out that the radius of this quarter circle R equals to the square root of 2 times x plus 4 units in its length. So the radius OP equals to the square root of 2 times x plus 4 units in its length. The next step, we implement the Pythagoras theorem on this right triangle PNPO. This right triangle NPO, PO squared, that is the square of the hypotenuse, equals to PN squared plus NO squared. Repeat again, this right triangle PNO, according to the Pythagoras theorem, PO squared, that is the square of the hypotenuse, equals to PN squared plus NO squared. PO is the radius of this quarter circle, equals to the square root of 2 times x plus 4, and therefore PO squared equals to the square root of 2 times x plus 4 squared. And it equals to Pn squared. Pn is x, therefore Pn squared is x squared plus NO squared. NO in total, it is 4, x plus 4 plus 3, that is x plus 7, therefore NO squared is x plus 7 squared. So in total, we should find out that square root of 2 times x plus 4 squared equals to x squared plus x plus 7 squared. We open the brackets on both sides of this equation and finally found out that the square root of 2 times x plus 4 squared equals to the square root of 2 squared, that is 2, and the square root of actually we have square root of 2 squared is 2, and we have x plus 4 squared. So in total, this expression equals to 2 times x plus 4 squared, and it is equals to x squared plus x plus 7 squared. X plus 7 squared equals to x squared plus 7 squared, that is 49, plus 2 times x times 7, that is 14x. So in total, we found out that 2 times x plus 4 squared equals to x squared plus x squared plus 49 plus 14x. We open the brackets of this expression, so we have 2 times x plus 4 squared. X plus 4 squared equals to x squared plus 4 squared, that is 16, plus 2 times x times 4, that is 8x, and it is equals to x squared plus x squared is 2x squared plus 49 plus 14x. We open the brackets of this expression. 2 times x squared is 2x squared, plus 2 times 16 is 32, plus 2 times x is 16x. In the other side of the equation, we have 2x squared plus 49 plus 14x. Here we have 2x squared on both sides of this equation, so 2x squared will get cancelled, so we cancel 2x squared. On this side of the equation, we have only 32 plus 16x, while on the other side of the equation, we left only 49 plus 14x. So in total, we should find out that 32 plus 16x equals to 49 plus 14x. Here we subtract the 14x from this equation, and finally found out that 32, we have 16x minus 14x is 2x, and it's equals to 49. 14x minus 14x is 0. So in total, we found out that 32 plus 2x equals to 49. Here we subtract the 32 from this equation, and finally found out that 2x equals to 49 plus 42 is 17. So 2x equals to 17. Here we divide this equation by 2, and finally found out that x equals to 17 halves. Actually, this is 9 p.m. equals to x equals to 17 halves. The missing 9 p.m. equals to x and it equals to 17 halves units in its length. Our test is to find out the area of this quarter circle. the area of any quarter circle is equals to the area of the circle over 4. Why? Because the quarter circle is a 1/4 of a circle. Repeat again, the area of the quarter circle A or B must be equal to pi times the area of the circle squared, that is the area of the circle over 4. We already found out that the radius of the quarter circle equals to the square root of 2 times x plus 4, therefore the radius square must be equal to the square root of 2 times x plus 4 squared. So in total, the area of this quarter circle will be equals to pi over 4. We open the brackets of this expression. Square root of 2 squared is 2, and we have also times x plus 4 squared. So in total, the area of the quarter circle will be equals to pi over 4 times 2 times x plus 4 squared. 2 over 4 is 1/2, so this expression equals to pi over 2, and we have to multiply it by x plus 4 squared. But we already found out that x equals to 17/2, so we can substitute x by 17/2. We did it, so x is 17/2 plus 4 squared. So in total, the area of the quarter circle will be equals to pi over 2 times 17/2 plus 4 squared. Here we multiplied 4 by 2, and then we divided it by 2 in order to overcome factor with this number. So we have pi over 2 and times 17 over 2. 4 times 2 is 8, so we multiply 4 by 2 and then we divide it by 2, so we change nothing. So in total, the area of the quarter circle will be equal to pi over 2. We have here 17 plus 8 is 25 over 2 squared. So the area of the quarter circle will be equal to pi over 2 times 25 over 2 squared. So this pi over 2, and we have 25 over 2 squared. 25 over 2 squared equals to 25 squared, that is 625 over 2 squared, that is 2. So in total, the area of this quarter circle will be equals to, in the numerator of this expression, we have 625 over 2 times 4, that is 8. So in total, we should find out that the area that we are looking for in this question, that is the area of this quarter circle will be equals to either 625 pi over 8 squared inside, so in terms of numbers, the area of this quarter circle will be equals to 245.437 squared in size. Okay, thank you very much.